So you're going to need a couple things as we debrief this. We are going to continue to work in those groups today. And I've got colors for our graphs available. So if you found colored pencils or markers helpful yesterday, you want to go ahead and grab those again. And you want to sit with the people that you were in a group with yesterday. I realized I had 4 people that were not in a group at all. If you were at the junior class meeting yesterday, you are going to be a group. So please go back to who you were with. If you don't remember who you were with, raise your hand. Okay. Please get back together with the people that you were working with. And I had a couple groups with 3, so you guys can join one of those groups, okay? So as soon as everybody else moves out, we'll see where our smallish groups are, and you're welcome to join one of those. I actually think I had 2 groups of 2 yesterday, so that'd be perfect. You could join one of those. Yes?
How do you explain that the x-axis is not labeled like the floor? How do I explain that?
I mean, it does have labels, right? But why is the way they're presenting it problematic? I like what you're saying here. The X scale is not labeled. What would you want to see different about it?
Oh, okay.
You're welcome. So yeah, just tell me what you'd want to see different. And we will go over something very similar to that in our debrief today. Okay? Thank you, ma'am. All right, juniors that were not here yesterday. We are on the back side of the piece of paper in your packet that has an artist's palette, a computer, a bunch of people singing. We are on the back side of this piece of paper right here. We did the front side together yesterday. People had time in their groups to answer the questions on the back, and now we're going to debrief them. So far, so good? Cool. All right. If you have not gotten these notes off of Canvas, you'll want to make sure to grab those. I do have those up under yesterday, but I am going to scoot past this real quick. And gentlemen, I'll show you where on Canvas you can find those pieces.
I'm not in it yet. I'm not in the Canvas.
You're not in the Canvas yet. I'll still show you where it is so that when you're added, because it'll probably happen at midnight tonight, you know where to go to get in. All right. How many variables does the table have? So when it says the table, it's talking about down here at the bottom, same one that we made in class together. How many variables are there? 2 variables. Are they categorical or quantitative? Categorical. How did we decide that they were categorical again?
Core class. Is that what y'all doing, right?
Yeah.
The core class.
Core class is a variable, and then elective was a variable. So it's like saying, which of these core classes is your favorite? You picked a category from that group. The group is my variable. Same thing with the elective. What's your favorite elective? And then you picked one from that group, one of those particular categories. How do we decide whether it's categorical or quantitative again?
Categorical is if you're picking something. Quantitative is if you're putting in a number.
Absolutely correct. Categorical, you're going to pick one of these categories. It's kind of like if you're taking a survey and they say select one option below that best describes you. That's categorical. Quantitative, you're going to enter an actual numerical value. Which variable would best explain or predict the other? What do you think? Yes. Core class. Could predict. Favorite elective. If you already know that somebody is a math person, My leaning is if I'm like, I wonder, yeah, I think maybe the math kids would like the technology classes. I think and it's not saying that I'm right or wrong, it's saying that I believe that I could use this to predict the other. We'll learn later on in the course, much later on, how we could test that kind of a prediction to see whether it's accurate or not. This thing that we think we can use to make predictions, this is called the explanatory variable. The variable that we're trying to make a prediction about is called the response variable. All right. So I want to use the information that we had from our table. And those of you that weren't here yesterday, everybody in class participated in this. They chose their favorite core class, their favorite elective, and then marked appropriately on this where they felt they fell. We're going to go to Staplet. We're going to enter this data. How many variables do I have this time, though? 2 variables. 2 categorical variables. We're going to make a side-by-side bar chart, and then we're also going to make a segmented bar chart. So I'm going to go here. Yesterday we did 1 categorical variable. This is Staplet. 1 categorical variable, multiple groups. That's what I'm going to click on. There we go. No, I lied. 2 categorical variables. Here we go. So I'm going to enter it in here. And hopefully I can actually make this work. I hate having to run back and forth on this. So we said our response variable was what? Favorite elective. Where did that? Oh, shoot. And now it's not going to let me do that, is it? Nope, of course not. And our explanatory variable for class. So, of my explanatory variables, what were our 2 groups there? Math and English. Response variables, what were our options? Art, music, PE, and foreign language. I'm going to go ahead and fill in these values from our table. PE, we had 0 and 4. One and 1, and then technology. 1 and 1. All right, let's check out this graph, and we're going to copy it onto there if you did not already do so yesterday. Moving forward, when we need to make graphs and stuff, I want you guys to do this in your group, and then I'll probably throw up like a sketch of what it is rather than going through Staplet each time. Begin our analysis here. We want to do a side-by-side bar chart. So this guy right here is what we want to sketch on our page. It does not have to be perfect, but we do want to get a sketch here. Ooh, and I want frequency, not relative frequency on the vertical axis. My apologies. We had no more than 4 people give an answer for any one of those individual joint frequencies. make a quick sketch there. We're also going to make a segmented bar chart when we're done in this same space, which in Staplet, I can change it to be a segmented bar chart now just with 2 clicks, and it'll show me that graph. With a side-by-side bar graph, I want the frequency on the vertical axis. But with a segmented bar graph, we're going to do the relative frequency. And I will explain the difference between those two in just a moment. Yes, ma'am.
For the side by side, I did it like kind of different than that. I separated it by, I did like art, and then I did side by side, one for math and then one for music.
Oh, I see what you're saying. So you had like these 2 light blue that are the arts, you had those side by side.
Yeah.
So that is a great thing to point out. When we're talking about a side-by-side bar chart, that's great for comparison purposes. When they use the phrase side-by-side bar chart in statistics, you've got an explanatory variable and explanatory variable. Sometimes there's more than 2 categories in your explanatory variable. And then you would have all of the bars that fall there that way. If you did it differently on your page, just make a little note like group all the math together and all the English together. It sounds like from the way you're describing it that instead of core class as your explanatory variable, you had elective as your explanatory variable. And so it's not necessarily incorrect. Maybe you said, I think the favorite elective would help me predict the core class, in which case your explanatory and response would be switched. So it's not like wrong. Does that make sense? Okay. Yes, sir.
So the explanatory variable is the math and English, right?
That's what we said, yes. And I'm not saying that that is 100% right. When we go later on in the spring and we start talking about hypothesis testing, where we will say, I think the core class would help me make a prediction about favorite elective. And then we can go in there and test that. Somebody else might come along and say, well, I think the opposite. I think favorite elective could help me predict core class. And those would both be testable things. Does that make sense? Okay. You guys have a basic sketch of this guy down? Okay. For a segmented bar chart, we use something called relative frequency. Not a mosaic plot, sorry. There we go. And I still clicked the wrong thing. Here's our segmented bar chart. And as you guys are copying this down, my question for you is, what do you notice about this? What strikes you about these 2 bars? Yes, sir.
English is more diverse in the favorite, the elective.
Mm-hmm.
And math is like, math only has 3 categories.
Yes. Math, we got 3 categories. English, we've got all 5 represented there. Some of the segments are pretty small. Does anything else stand out to you about this? Percentages. We've got our relative frequency over here. And both of them go all the way up to what? 100%. How's that possible? Yes, ma'am.
Because it's dividing, it's not the total of 17, it's the total of what is math.
Yes. Yes. We have our relative frequencies here. So when it goes up to 100%, it's just saying 100% of all the math students, or people that chose math as their favorite core class. This is 100% of all the English students. This is not saying that the same number of people chose math as chose English. In fact, if I look over here, where did more people definitely fall in this class? English, like heavily. we had only 4 people choose math as their favorite out of 17. So when I'm saying 100%, I'm saying out of the 4 students that chose math as their favorite course subject, here's the breakdown. This allows me to visually compare percentages here. You guys see that? At a glance, if I said, so who's more likely to prefer music? Would it be my math kids or my English kids? Proportionally, it's my math kids. Absolutely. Who is more likely to prefer PE? English. Nobody in math even chose that one, right? All right. Do you guys feel like you have a reasonable sketch drawn? If I need to stay here for about another 30 seconds, I can do that. I don't want to scoot on too fast. All right. I do want to answer the questions down at the bottom, 9, 10, and 11. If you, let's see, how do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? How do these 2 visual representations relate to each other? Let me go back and we'll get the side by side. And segmented. When I'm looking at side by side, what's the highest one for math? Music, right? And then we've got foreign language and tech that are both exactly the same, correct? Let's go look at that segmented. What do you notice here? Same thing. So it's kind of like I took those bars and just stacked them on top of each other. Made it a little wider so it was easier to see and not so tall. But I just took the bars from my side-by-side bar chart and stacked them one on top of the other to get my segmented bar chart. So let me write that down. If you stacked all the bars, we only looked at math, so I'm going to say that. For math, from the side-by-side bar chart, the stack would look like the math bar in the segmented graph. Do you think, based on our graphs, that there is an association between favorite course subject and favorite elective? Do you think that we could make an argument that there is an association between favorite course subject and favorite elective? Why or why not? What do you see? You can look at the raw data, or you can look at our segmented bar graph. if you knew that someone's favorite core subject was math, and I asked you to then make a guess about what their favorite elective was,
It doesn't.
you don't think you could really make an argument there? What about if you knew someone's favorite core subject was English? Could you say anything predictive at all about what their favorite elective would be? Like more likely or less likely?
I assume art. That's close.
Absolutely.
Yeah.
Looks like if someone's favorite core subject is English, they are more likely to have art as a favorite elective than if they say math is their favorite core course. Do you guys see that?
Yeah.
Are there any other statements that you feel like you could make given our data?
You can say the same with PE.
You could say the same thing with PE. So if you say that English is your favorite core subject, those individuals are more likely to have art or PE as a favorite elective. And you guys said based on our math group, we don't feel like we could make that same kind of a statement. Is that still true? And it's okay if it is.
You could say math and music.
Math and music. Granted, we don't have a ton of data to work with, but based on the data that we do have, it appears...
Or could
Yes.
you say if your favorite is math, they're less likely to take art or PE?
Yeah, I think you could probably say that since those categories were zeros in our particular group. You could say someone whose favorite core subject is math is less likely, based on our results, to choose PE or art as a favorite elective. All right. I'm curious, on a bar chart like this, and this is question 11 on your page. So we answered question 10 verbally. Do you guys want to see me write something down? It's really just what we said a moment ago, where we said it appears that if someone selects English as their favorite core class, they are more likely to select art or PE as their favorite elective. It appears from our data collected that if someone selects math as their favorite core class, they're more likely to choose music, or conversely, you could say less likely to choose art and PE. What do you think we would see visually on this segmented bar graph if we were going to come to the conclusion that there doesn't seem to be any association at all between favorite core class and favorite elective? Yes, sir.
I figured that like the graphs would look really similar since there's like no preference for a particular elective.
Yes, absolutely. So I'll go ahead and write that one down for number 11. I'm going to basically repeat what you just said. We would not notice any differences between the bar for English and math. So the segments would all appear to be about the same size between the two bars. 25% here, 25% there, 50% here, 50% there. In that case, I would say that core class probably wouldn't be a good predictor if that's what we saw. Like, there doesn't appear to be any difference between these two. Segments would be the same size. So looking at our time and knowing what we need to cover, I had originally a different activity planned for mosaic plots, but we can do it with this information here as well. So there's some cool and useful things about a side-by-side bar chart. Lets me compare proportions between these groups. Segmented bar chart is really helpful to try to see if these two groups are similar. But this leaves out some information that might be important for me to analyze. Based on the way the graph looks, if you hadn't helped me collect the data, if we didn't have our raw data over here, what might you assume about these two core class groups? Yes, ma'am?
That math had a lot more answers than English, where they were like the same sort of size.
Yeah. I have no idea from the way this segmented bar graph is drawn that there were only 4 kids who chose math and that there were 13 who chose English. I have no idea about the size of these two groups. That's what a mosaic plot will do. With a mosaic plot, I see not only percentages here, but we decide how wide to make these bars here instead of making them the same width. We make those represent, come on, the size of our two groups. Now when you look at this, do you see a substantial difference in the number of students who said math versus the number of students who said English? All right. I want to try to find a place to draw this one. On the back side of the 3rd page, it is blank. So this would be like you flip to the next page, like turn your packet just over, like we're going to do the next activity, and then the back side of that is blank. Let's sketch this mosaic plot there. Yes, sir?
I was wondering if someone might purposely like not use a mosaic to kind of like mislead people and think like it's a bigger group than usual.
That is a great thought. Graphs absolutely get used in misleading ways. And I think sometimes it's intentional. I think sometimes it's unintentional. You know, the person collecting the data might say, well, I know that there were way fewer people than, in math than English, and so I'm just going to compare these two percentages. And they're not intending to mislead the audience that is then the receiver of that information. A mosaic plot, I definitely agree with you that this is a much more accurate way of saying, like, here's the size of my two groups. So yeah, I think it can be used intentionally to mislead, or it might be unintentionally misleading. What do you notice? They've written it across the top, but what do you notice about the top of this mosaic plot? I have my percentages here. So I can see what percent of the overall group. I'm still giving relative frequencies, so 4 out of 17 to get that number that's slightly larger than 20%. 13 out of 17 to get that value that's just a little bit less than 80% for my English. I had never seen a mosaic plot before until studying to teach AP statistics, but I do feel like it can be a little bit visually confusing because it's all smashed together, but I think it gives a more accurate representation. A mosaic plot is going to allow me to make some statements about the whole group. So I could talk about what the most likely thing would be for the entire class, which would be a joint relative frequency. Without looking at the raw data, as you're looking at this mosaic plot, if I were to ask you to guess the the favorite elective and the favorite core class. What appears to be the most common choices in this class? Art and English, PE and English. Those have the largest area on my graph, and so those are the most likely choices from our students. I want to fill in, there is an empty box. It's on the back of the page where we were originally drawing the graphs, or where we just drew this mosaic graph, I apologize. It says analyzing categorical data. If you've drawn something in there, there is a similar box on the back of the next page. So we can kind of fill that in, or you can write on the back side of that page too. That's totally fine. I want to fill in some other pieces of information. You guys okay if I take this graph down? Okay. All right, so analyzing categorical data. I'm going to have a couple things to say here. We're going to talk about categorical data. We want to report the frequencies or the counts. Do you think it would be important to distinguish between those two, whether you're providing a count or a frequency, or sorry, count, frequency, or a relative frequency? Do you think it would be important to distinguish between those? If it says frequency, that just means a count. So if it says frequency off to the side and it goes up to 10, like there were 10 people that said that. If it is a relative frequency, they're going to give it to us in what way? Percentages. Here, I'm actually going to pop parentheses around this. The frequency, which is counts, or relative frequency, which would be percent. In bar graphs. Pie charts. Side-by-side bar graphs. What other kind of graphs did we look at here? Mosaic. Anything else? Segmented. So we're going to write both of those down. Segmented bar graph. And mosaic plots. We talked about this briefly, and it got brought up several times, misleading graphs. What are some things that we'd want to watch out for with misleading graphs? axis. Watch out for your vertical axis. Should start at 0. Why is it visually misleading for it to not start at 0? Yes, and I feel like you said this before, but then I got lost in my own words up here. Yes, if it doesn't start at 0, then sometimes there might be numerically a minor difference between two groups, but the way I've presented the information, it makes something look twice as likely as the other, when it's really not. Does that make sense? A lot of people, think about your standard consumers of news, whether they're getting it from the internet or from the television or wherever. Are they usually deeply analyzing graphs that are presented to them? No. Especially if it's on TV, they show it to you for a couple of seconds, they'll talk about it for a little bit, and then they move on. And what's left in your brain is that visual image. And then you take that visual image, the next time you hear about information, you're like, oh, wow, well, this was, like, that bar was this big. That's way more likely than this other thing. Well, if they're starting their count at 80, and this is 81, and this is 89, it's not really as far apart as they're making it appear. Be careful of pictographs. Do you guys know what I mean by a pictograph? Pictures, basically, where instead of using bars or something kind of neutral to represent your data, I saw this actually in my daughter's first grade room when I went to meet the teacher night. They have like, how many people have birthdays in April? And they have an apple for each person who has a birthday in April. And then you can use that to make different kinds of graphs. It's not that they're always inaccurate, but they can be manipulated. Think about the way you make an image larger or smaller on the computer. It makes the whole thing bigger, right? So if I was doing a pictograph about your favorite subject and I picked out some images to represent each of these and I just scaled it up, some of these images are going to not just appear taller, they're going to appear wider, which gives the impression that it is much more likely because I see it swelling in all directions. So just be careful. It's not that they're always misleading, but be very careful. All right. Last thing I kind of want to get down here, two-way tables. This is for two categorical variables. So we're going to have variable 1 on one side with its categories and variable 2 on the other side with its categories. All right, I'm going to label a couple things in here. I'm going to call this A, B, and C down here. C would be what, do you think? It's not even in the table, right? This is my grand total. So what do you think B is? Yeah, it's like a row total. I could also do this with column totals and it'd be the same thing. So marginal relative frequency. I'm not going to write the whole word down because I don't have enough room, but marginal relative frequency, I have B divided by C, coming from the margins. For joint relative frequency, I'm looking for the joining of a row and a column over my total. For conditional, I am only looking at one row or one column for my total. So I have joint in the top and marginal in the bottom if I'm looking at conditional. An association between two variables means that I see there's a relationship between those two. It's the last thing I'm going to write down. Knowing that one affects the other. All right. I passed out homework yesterday towards the end of class. If you were not here yesterday, or you do not have the homework, please come see me. This guy is due on Monday.